Hello, my amazing Java learners. Welcome back to the channel. Today, we are diving deep into one of the most fundamental and powerful concepts in the Spring framework, dependency injection. Even though it sounds advanced, I promise to make it super clear and easy to understand. We will explore what dependency injection is, why it is so crucial for building robust and maintainable applications, and how Spring makes it effortless for us. By the end of this tutorial, you will have a solid grasp of how to leverage dependency injection in your own Java projects. So, grab your virtual whiteboards, and let us begin this exciting journey. Alright, let us start by understanding the problem that dependency injection solves. Imagine you have a car class, and this car needs an engine to run. Without dependency injection, your car class would typically create its own engine object directly inside its constructor or a method. This approach, while seemingly simple, creates a tight coupling between the car and the engine. The car is directly responsible for instantiating the engine. What if you want to use a different type of engine later, say an electric engine instead of a petrol engine? You would have to modify the car class itself. This makes your code rigid, difficult to test, and hard to maintain. This tight coupling is a significant hurdle in developing flexible and scalable applications. This is where inversion of control, or IOC, and dependency injection, or DI, come into play. Instead of the car creating its own engine, we invert the control. Something external provides the engine to the car. In Spring, this external entity is the Spring IOC container, also known as the application context. The container is responsible for creating objects, wiring them together, and managing their entire life cycle. Dependency injection is the pattern that implements inversion of control. Instead of the car pulling its dependencies, the dependencies are pushed into the car by the container. The most common and recommended way to do this in Spring is through constructor injection, where dependencies are passed as arguments to the class's constructor. Let us look at a practical example to solidify our understanding. Consider a user service that needs to interact with a user repository to perform operations like saving or retrieving user data. Without dependency injection, the user service would create an instance of user repository itself. With Spring's dependency injection, we simply declare the user repository as a dependency in the user service as constructor. We annotate the user service with @service and the user repository with @repository, telling Spring that these are components it needs to manage. Spring will then automatically detect these components, create instances of them, and inject the user repository into the user service when it creates a user service object. This way, our user service does not know how its user repository is created, it just knows it needs one, and Spring provides it. This makes our code much cleaner and more modular. While constructor injection is generally the preferred method, it is important to be aware of other types of dependency injection and some common pitfalls. Besides constructor injection, Spring also supports setter injection, where dependencies are injected via public setter methods, and field injection, where dependencies are injected directly into fields using the @autowired annotation. However, field injection is often discouraged because it hides dependencies and makes testing more difficult. Common mistakes include forgetting to annotate your Spring components with @component, @service, @repository, or @controller, which prevents Spring from discovering them. Another pitfall is circular dependencies, where two beans depend on each other, which can lead to runtime errors or unexpected behavior. Always prioritize constructor injection for mandatory dependencies and be mindful of your component annotations. And there you have it, folks. We have covered the essentials of Spring Dependency Injection. We learned that dependency injection is a powerful technique to achieve loose coupling, enhance testability, and improve the overall maintainability of our applications. Spring's IOC container simplifies this process by managing our application's components and their dependencies automatically. Remember, the core idea is that components declare their dependencies and an external entity, the Spring container, provides them. Keep practicing these concepts in your own projects. The more you use it, the more intuitive it becomes. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to the channel for more exciting Java and Spring content. Your support truly motivates me to create more such videos. Happy coding, and I will see you in the next one.